Hello everyone, very good morning to one and all. Myself Dr. Amjad Basha, Assistant Professor from the Department of Mathematics, the New College. In this lecture series, I am going to explain you about binomial expansion. In particular, I am going to use summation of series using binomial expansion. If you want to go for summation of series, three points have to be observed. Point number one is the factors in the numerator are in arithmetic progression. So when you take the factors of the numerator, you need to check whether they are in AP, which means it should have a common difference. The second point is that the factors in the denominator are the multiples of some number. In this problem, we have the denominator as multiples of 4 and the numerator have the common difference as 2. And the third point is that each successive term has one additional factor in the numerator as well as denominator. Even that is being observed here. So when all the three cases are observed, you can use summation of series formula to find the sum of this given series. So let me solve this problem now. To start with solution, name this as S is equal to 1 plus 3 by 4 plus 3 into 5 by 4 into 8 plus 3 into 5 into 7 divided by 4 into 8 into 12. This is the series, infinite series we have. Before you proceed for the problem, you just put a note about all the three cases. That is, the numerator of the series is in AP with a common difference that is Q is equal to 2. In this case, let me name the common difference as Q. Okay, or you can name it as P as well. Let it be Q, no problem. And the multiples and the denominator has multiples of 4 and there is one additional factor, and there is one additional factor in each successive term. Just make a note of those three cases so that it will be clear. Then what you have to do is arrange the series to the required binomial expansion for rational index. So I'll put it in this way, that is S is equal to 1 plus 3 by that 4, I'll just put it in this way, 1 into 4. Similarly 3 and 5 can be written as 3 plus 2. Okay. 3 plus 2 divided by 1 into 4 and 2 into 4. That is 4 into 8 can also be written as 1 into 4 and 2 into 4. Similarly, the other term can also be written in the same manner. That is 3 into 3 plus 2 into 3 plus 2 into 2 divided by 1 into 4, then 2 into 4, 3 into 4, so on. So the series goes on like this. So again, when I simplify this, let me put it in this way: 3 by 1 into 1 by 4 plus 3 into 3 plus 2 divided by 1 into 2 into 1 by 4 plus 3 into 3 plus 2 into 3 plus 2 into 2, the whole divided by 1 into 2 into 3 into 1 by 4. Here I have square, here I have cube. Okay, here I have cube. So the series goes on like that. So when I compare this with the binomial expansion, let me move on to the next slide. So the above series I will compare with the expansion, that is compare with the binomial expansion. One minus x the whole power minus p by q, which can also be written as, the series goes like this: 1 plus p by 1 factorial into x by q plus p into p plus q divided by 2 factorial into x by q the whole square plus p into p plus q into p plus 2q divided by 3 factorial into x by q the whole square, whole cube, so on. The series goes like this. So when I compare the previous one with this, it is very crystal clear that what is p, what is q. Look at this, my p is 3 and my q is 4, okay, and my x by q is 1 by 4. So if you put it in that way, your p is 3, look here. So when you compare, your p is 3, your q is 2 and your x by q is 1 by 4. So when you substitute your q value, you will be getting your x. So x by 2, which is equal to 1 by 4, which implies your x is equal to 2 by 4, which means your x is 1 by 2. Now you got your x value, your p value, your q value. All these three values I will be substituting in this series to sum the series of the given binomial expansion. So s is equal to 1 minus x, or better I will put it in the other slide. So all these values I will put it in the required series, that is, the series can also be written as s is equal to 1 minus x the whole power minus p by q. So I know my x value, p and q value as well. So I will be substituting here 1 minus your x value is 1 by 2, the whole power minus your p value is 3 and your q value is 2. So s is equal to, if you take the LCM, 2 minus 1 by 2, the whole power minus 3 by 2. So s is equal to 1 by 2 the whole power minus 3 by 2. Okay, so when you move on to the next, what I am going to do is 1 by 2 the whole power minus 3 by 2 can also be written, just I will continue with the previous step. This can also be written as 2 power 3 by 2. Okay, so 1 by a power m can also be written as a power minus m. So minus of minus become plus. So this 2 power 3 by 2 can also be written as 2 power 1 into 2 power 1 by 2. So s is equal to 2 into 2 power 1 by 2 is root 2. Therefore, the required sum of the series of the given expansion is s is equal to 2 root 2. Hope you all understood. I repeat from the beginning. So to find the sum of the series, to find the sum of any series, in particular in binomial expansion, you need to check whether three cases are being satisfied. Number one, to check whether the factors in the numerator are in arithmetic progression. Number two, the factors in the denominator are multiples of some number. And number three, each successive term has one additional factor in the numerator and denominator. Since all the three cases are being satisfied in the given series, it is very clear that you can proceed with the binomial expansion. There are some problems in which the given series may not be in binomial. So in that case, in the standard form of binomial, I could say. So in that case, what all you need to do is that you need to check whether which term is being missing. In some problem, only the first term will be missing. In some problems, first and second term will be missing. In some problem, sign wise it will be missing. You should have alternate plus minus, even that may be missing. So first thing is you need to observe the given problem very carefully. Which term is given, which terms are given, which is missing, which is not, whether the complete series is given or the given series itself is incomplete. Once you analyze everything, understand clearly, only then you need to proceed. Let us assume that in some cases, suppose one is missing in this given problem. Suppose, let us assume that if one is missing, then what all you need to do is that you need to add one on both sides. So you will add one to the left hand side as well as to the right hand side. On both the sides, when you add one, you will get the standard binomial series. Okay. So finally what you will be doing is, once suppose if you could have add 1 here, finally that plus 1 will come to the other side, that is on the right hand side. Your final answer could have been s is equal to 2 root 2 minus 1. On the other hand, suppose 1 plus 3 by 4, first two terms are missing, then what you will be doing is, you will be adding 1 plus 3 by 4 on your left as well as on your right as well. Once you do that, the given series will be in the standard form. Then you will proceed with the corresponding binomial expansion series formula to find its series. Then finally, whatever you have added on your left, everything will come on your right side. Again, you need to simplify that. If possible, you simplify. Otherwise, you just bring to the right hand side and keep as such. That is how you need to solve any summation of series using binomial expansion. Thank you so much. Bye-bye.